Good afternoon, ladies and gentlemen. Today is Wednesday, the 24th. I know it's been kind of a challenging week since I've been busy in testing. Hopefully you guys have been signing in to Schoology and making sure you do what you need to do. So what I've done today is I've posted a bell ringer, a radiation review, and then kind of a topic reviewing the science probe and the worksheet answers. So remember that tomorrow you will have a test, your third major grade for third quarter. In general, if you've been following along with the worksheets and doing what you're supposed to do in the Nearpod, you should be very, very, very well prepared for this test. So let's take a look at the bell ringer. The bell ringer was kind of simple here, and I asked you to compare convection, conduction, and radiation. So remember that convection involves fluids like liquids and gases and the movement of heat through those. Conduction typically occurs in solids where two surfaces come into contact. And then radiation is thermal energy that is transferred through a wave pattern. And one of the primary examples of radiation in the form of thermal energy is heat we feel from the sun. So I'm going to go over each of these in more detail in a few minutes when I go through a brief little PowerPoint presentation. But that's your bell ringer there. Make sure that you've addressed that. The next thing I had for today was a radiation review. These were Nearpods that you should have been able to work through and practice your concepts. So make sure that you go back to this one. And in yesterday's folder for Tuesday, March 23rd, there was a Nearpod for convection and conduction. So these were basically short Nearpods that reviewed each of these concepts. Yesterday's bell ringer said if two objects or containers have the same temperature, but one has a larger mass, the correct answer was in fact A. The larger mass object has more thermal energy. So it doesn't matter about the temperature necessarily. So you could have a large block of ice or a small lit match. Obviously, the lit match has a higher temperature because there's a flame burning, but it's not going to have enough thermal energy to transfer to the large block of ice. So yes, the ice is colder, and yes, the ice will eventually melt. But because the block of ice has such a large mass, a small match isn't going to do very much. So that's basically your bell ringer for Tuesday. So now that we've gone over that, I'm going to bounce back in to Monday. We will take a look at this bell ringer. So for Monday, blank is a measure of the average kinetic energy of the particles in a material, and the correct answer is in fact temperature. So we've gone over those three bell ringers. If you had issues with the thermal energy Nearpod not working, that's not a big deal. That was just kind of a practice and review. However, you should have been able to get the Nearpods from yesterday, convection, conduction, and the Nearpod that was assigned for Wednesday, March 24th, radiation. These were all three very good reviews of those three topics, which will be on your test tomorrow. Now, this last segment is just a brief explanation of the science probe that we looked at earlier in the week and answers to the worksheet that you were assigned last week. So the mitten problem was posted early on, sometime last week. So I'm going to actually pull that up really quickly. So I'm going to go back into last week's folder. And I know that some of you, most of you were in testing, so some of you may not have even gone back to look at this. You should have. Just because you were testing doesn't mean you're exempt from all of the work. But let's take a look at the mitten problem anyway. All right, so everyone should see this now. So here's the mitten problem. And they basically left a thermometer out, one on the table, one in a mitten. An hour later, they compared the readings of the two thermometers. What should you have observed? Well, you should have observed C, that both thermometers will have the same temperature reading. And the reason behind that is because both of them were left out and exposed to normal room temperature. So this one would be the same temperature as the air in the room, and so would the one in the mitten. Secondly, to explain this, thermal energy has to come from somewhere, right? Energy does transfer through objects. In order for these two thermometers to have different temperatures, one must have more thermal energy than the other. Mittens do keep our hands warm, but that is because they prevent your body heat. They trap your body heat, basically. They prevent your body heat from leaving your body and moving out into the external environment. But thermometers don't generate their own thermal energy. So these two thermometers would both have the same temperature reading. So now that we've gone over the mitten problem, I'm going to go back into Schoology. Also last week, let's see, you had the mitten problem one day. You should have made a foldable. And you should have worked on the methods of heat transfer worksheet. So when you open this up, it popped up a few different scenarios and then fill in the blank. This is the worksheet, methods of heat transfer, that goes along with the answer key I posted. So once you have this up, you should have worked on this and submitted it. You can go back into third quarters folder this week, and in today's assignment, I provided you with the answer key. So this answer key goes along to this document here, and you can check your work to make sure you have the correct answers. This answer key is going to also act as a study guide for you. Goes through the definitions and through each of the scenarios and examples that were included in the worksheet. So basically what you were doing here is identifying the different forms as convection, conduction, or radiation. So now that we've gone over that, the last thing that I'm going to do with you guys is I'm going to share with you a quick little PowerPoint, just kind of going back over those three primary topics and reviewing them with you. So here, this example of quick little PowerPoint, heat transfer in the atmosphere. So this does use the atmosphere as an example towards the end here with convection, but in general, it talks about heat transfer and the different types. So let's take a look at this now. So what is heat transfer? Remember, that is the movement of heat energy from one substance to another. Heat energy always moves from warm to cold. Always, always, always moves from warm to cold. Cold never moves. So it always moves from warm, or the red block, to blue, the cold block. What about heat transfer? Why does it continue to happen? How long will it happen? Well, it's going to continue to happen until equilibrium is met, or until both objects have the same temperature. So it will continue to do that until they have reached the same amount of thermal energy. The greater the difference in temperature, the faster the heat transfer will occur. So the three main forms of heat transfer are conduction, convection, and radiation. So these are the three that we're primarily going to be discussing, and the three that will be on your test tomorrow. Here are some good examples and then some non or anti-examples. You touch a black car in the summer and the heat from the car transfers into your hand. A breeze makes you feel cooler because the wind transfers heat away from your body. You feel the cold of a winter day because the cold air transfers into you. Or your Coke in a cooler gets cold because the cold from the ice moves into the Coke. These two would be poor or anti-examples. So notice the difference here. This talks about how you transfer heat energy from warm to cool. And in these examples, you're moving from cool to hot. But as we just learned on the previous slide, warm is what moves, not cold. Coldness doesn't move. So one of the first forms, conduction. The key with conduction is that it usually occurs in a solid and the two substances must be touching, similar to this example here. Direct contact. And because they're in direct contact, the molecules are going to transfer energy directly to the molecule beside them. It doesn't matter what type of substance it is. Typically it is solids, but it could be solid food on a frying pan. That would be still an example of conduction. Or you could be heating soup in a pot on the stove. Soup would still be considered a liquid, but it is still warming because of conduction of thermal energy through the pot. This is a great example. Notice there are 2 cups of water. One is warm, one is cool. Over time, the cool water will become warmer and the temperature in the warm water will drop. And this will continue to happen until they both have the same temperature. And that's because they are connected with this kind of curved piece of copper. And copper is a good conductor of heat. So thermal energy will transfer from the warm cup up through the copper down into the cool cup. Second example, how does ice work to keep your soda or other drinks cool? Well, the ice cubes pull heat energy from the soda into the ice cube itself. And that's how it cools the soda down. So you have a transfer of thermal energy. That also explains why your ice cubes eventually melt. So remember, cold does not transfer, no matter how cold it is. You wear heavy coats and jackets because you're trying to trap your body heat inside and prevent them from transferring, or prevent your body heat from transferring to the surrounding environment. The second form of heat transfer we've been talking about is radiation. This is basically the movement of heat through electromagnetic waves. What's interesting here is that there is no direct contact, and there doesn't have to be. That's because radiation heat energy can move through with no medium. Doesn't have to be in contact. It moves out from the heat source in a wave-like pattern and then is absorbed by other sources around it. So in this example, it's moving away from the red source into or towards the blue source, which has a cooler temperature and less thermal energy. One primary example is the sun. This is how heat energy makes its way to the earth. Radiation is also why your back begins to feel hot when you're at the beach, leaning over, building a sandcastle, or reading a book. After a while, from the sun shining down on your back, it starts to get hot because of radiation thermal energy transfer. This is also why when you hold your marshmallow out to the side of a fire, so even if your marshmallow doesn't touch the flame, it will eventually heat up and become kind of melty and gooey, and that's because of radiation thermal energy. The third type of heat transfer is convection, and this is the transfer of heat through the fluid of liquids and gases, and they move in kind of a current or a circular pattern. So basically, warm air is going to rise, and then as it cools down, it's going to sink again. So cool is going to sink and warm is going to rise, and it's just going to kind of keep doing the same thing over and over again. This is a better picture here to illustrate that. If you had a room with a radiator heater, or just like a heat source, here's a radiator. So the warm air thermal energy rises and rises, it hits the ceiling and curves over, and then it's going to start to cool down. And as it cools down, it'll start to fall back down. And then if it gets sucked back into the radiator, the heater goes back up, and it just kind of keeps happening. So a radiator warms the air around it, warm air rises and transfers heat, and then it cools, and the cycle will continue. This is also what drives weather patterns on our planet. The sun, through radiation thermal energy, heats the Earth's surface. It heats the air, so that warm air rises up, and then it cools down and flows and sinks back down. And that's why we have wind and different weather patterns that exist on the planet. This is the last example here. If we could hold a pot over a fire, we could identify 3 different types of heat transfer. So the first, that's moving out to the sides, this direction, is radiation. Notice it's moving in a wave-like pattern. So this is why if you sit around the edge of a fire, you can feel the warmth. Above the fire, you actually have convection. So this explains, remember, convection occurs in fluids like liquids or gases. So the air above a fire begins to get really hot, warming up, thermal energy is being transferred, so convection starts to occur. That's why when you see a fire that's burning a lot of stuff, you will see ashes and things just kind of go way up in the air and fly off from the fire. That's because of convection. So you could observe convection currents on the top of the fire here. Also, if you have a pot that you're holding over the stove or over a fire, if the water starts to warm and move up, warm water rising, cool sinking, you end up with a convection current in the pot. And then lastly, if you were holding on to the pot handle without a pot holder and it wasn't an insulated rubber handle, you might burn your hand through the process of conduction or heat transfer from the pot directly to your hand. All right, so that's it for my review slide. So hopefully you guys now have everything that you need to be successful tomorrow. So don't forget, make sure you do the radiation near pod review and then the conduction and convection one that is posted in yesterday's folder for Tuesday the 23rd. I think you'll be successful tomorrow, so good luck. You will be taking your last and final test grade for third quarter in class tomorrow. Have a good night, you guys. Hopefully I can see you on the WebEx tomorrow.